Welcome to another episode of In the Field with McKim Creed. I'm Jacob Bowes, the Senior Project Engineer in the Raleigh Water Group, and today we're on site at the Lick Creek Lift Station in Durham, North Carolina. A lift station is designed to take wastewater flow from a lower elevation to a higher elevation whereby gravity flow can't be accomplished. McKim Creed's Raleigh Water Group is responsible for the design, engineering, and construction of the replacement of large isolation valves at the Lick Creek Lift Station. Replacement of these large isolation valves will help with enhanced operability and capacity for the city's system. The Lick Creek Lift Station serves a roughly 21,000 acre sewer basin in southeastern Durham County. These isolation valves are located on both the suction and the discharge side of the pumps. Here at the Lick Creek Lift Station, it's a wet pit, dry pit configuration. The dry pit is downstairs here beneath me, wet pit being on the other side of this wall. Since these large isolation valves were located on both the suction and discharge side of the pumps, a pretty significant temporary bypass operation was required in order to complete the work. The Lick Creek Lift Station is a quadruplex lift station, meaning that we've got 4 pumps that work to get the flow that comes into the station and pump it out. One of the things McKim Creed wanted to do in the design when they brought in existing record drawings provided by the city for this lift station was to be able to clearly show the access points for the contractor to how they were going to get down to the valves beneath us. You can see here on either side there's two fairly good-sized access hatches that provide a lot of space for the contractor to be able to put cranes and pulley systems down in to hook onto the valves, which are large and also very heavy, and pull them out. So I'm currently standing in front of the brand new isolation plug valves that are set to be installed in the dry well that we were in earlier. The Lick Creek Lift Station has got variability in flows, and one of the challenges that every pump station and lift station faces when gravity lines feed that station is understanding that there can be some infiltration and inflow that you've got to consider from a pumping perspective. The Lick Creek Lift Station is known to receive average dry weather flows at 2 MGD, peak wet weather flows at 11 MGD, but more so on average around the 4 MGD range. And it was very important that in the bypass plan that the contractor submitted and that McKim Creed accommodated in the specifications for the project that large variability in flows was considered. For any temporary bypass operation, it's really important that you have your pump sized appropriately and your bypass pipe sized appropriately. In this project, we've got a primary pump, this larger orange box sitting back here that's providing the main suction point for 2 24-inch gravity lines that feed this station. The effluent pipe shown here is primarily 24-inch HDPE fusible bypass pipe that's carrying the flow from those 2 gravity lines to a discharge location. The second half of a temporary bypass operation is the discharge side. The 24-inch line that's feeding towards the discharge location transitions to an 18-inch HDPE portion right here, which feeds an existing discharge standpipe that the Lick Creek Lift Station already had in place for us to be able to use in this project. This temporary bypass operation takes place 24/7. At this point, once the flow enters in from the bypass piping into the discharge, it feeds back into the existing 30-inch force main and pumps to the North Durham Reclamation Facility for treatment. Thanks for tuning in to another episode of In the Field with McKim Creed. We'll see you next time when we take a look at the Eno River Lift Station.